This is Spacetime, Series 23, Episode 16. Coming up on Spacetime, Magellanic Cloud stars discovered in the Milky Way. Will the first humans to Mars come home with brain damage from radiation exposure? And Iran fails in its latest attempt to launch a satellite into orbit. But then again, the launch was very successful if you're really testing a ballistic missile. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have discovered stars in the Milky Way which have been made out of material from two nearby dwarf galaxies known as the Magellanic Clouds. The findings, reported in the Astrophysical Journal and on the prepress physics website archive.org, means the pending collision between our galaxy and the Magellanic Clouds is happening far sooner than expected. Galaxies grow through a process of merger and galactic cannibalism as larger galaxies consume smaller ones. And our own galaxy, the Milky Way, is no exception. It's already consumed numerous smaller galaxies over its 13 billion year history, and is currently in the process of consuming both the Sagittarius Dwarf Galaxy and the Canis Major Dwarf Galaxy. The Milky Way is also starting to drag gravitational tidal streams of gas from the Large and Small Magellanic Clouds, two of our nearest satellite dwarf galaxies and clearly visible in the southern night skies. The Large Magellanic Cloud is the disrupted barred spiral galaxy about 163,000 light-years away. It's about 14,000 light-years in diameter and contains about 10 billion times the mass of our Sun. Its companion, the Small Magellanic Cloud, is an irregular dwarf galaxy about 200,000 light-years away, about 7,000 light-years wide, and about 7 billion times the mass of the Sun. They were considered our nearest neighbouring galaxies. That was at least until the 1994 discovery of the Sagittarius Dwarf Galaxy. And then it was surpassed in 2003 with confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The Sagittarius Dwarf spheroidal or elliptical galaxy is about 10,000 light-years in diameter, and it's currently about 70,000 light-years from Earth, travelling in a polar orbit. It's passed through the plane of the Milky Way several times, causing perturbations in stars near the Milky Way's core, resulting in unexpected rippling movements in the stars, triggered as it soared past the Milky Way between 300 and 900 million years ago. It's currently on the opposite side of the Milky Way from where the Earth is. Based on its current trajectory, the Sagittarius Dwarf main cluster is about to pass through the Milky Way's galactic disk within the next 100 million years or so, while the extended loop-shaped ellipse is already extended around and through our local space and through the Milky Way's galactic disk, and is now in the process of slowly being absorbed into the Milky Way. As for the Canis Major Dwarf Galaxy, it's an irregular galaxy located just 25,000 light-years away. That means it's actually closer to Earth than the centre of our own galaxy. It was first detected as a significant overdensity of stars. It's believed to contain about 1 billion stars, about the same as the Sagittarius Dwarf, with a relatively high percentage of them being red giants. The Canis Major Dwarf Galaxy is now in the process of being pulled apart by the gravitational field of the far more massive Milky Way. In fact, its main galactic body is already extremely degraded. Gravitational tidal disruption from the Milky Way has caused a long filament of stars to trail behind it as it orbits our galaxy, forming a complex ring-like structure, sometimes referred to as the Monoceros ring, which wraps right around the Milky Way 3 times. As for the Magellanic Clouds, they have also been greatly distorted by gravitational tidal interactions as they're slowly being torn apart and absorbed into the Milky Way. A flow of high-velocity neutral hydrogen gas, known as the Magellanic Stream leading arm, currently extends over 600,000 light-years from both the Large and Small Magellanic Clouds and through the galactic south pole of the Milky Way. The stream's composition suggests it's mostly composed of gas from the Small Magellanic Cloud, which is less massive and so less able to hold onto its gas. A separate stream of neutral hydrogen, known as the Magellanic Bridge, links the two Magellanic Clouds. Observations show a continuous stream of stars along the bridge, with a greater concentration of the stars at the western section. The bridge also has 2 major stellar density clumps, one near the Small Magellanic Cloud and the other midway between the two clouds known as the Ogle Island. The newly discovered stars, a cluster of less than a few thousand in total, could reveal new insights into the Milky Way's history and tell scientists if the Magellanic Clouds have collided with the Milky Way in the past. To reach their conclusions, the authors used the latest data set from the European Space Agency's Gaia spacecraft, which has been measuring and cataloguing the distances and motions of more than 1.7 billion stars. The team began by looking for very blue stars, which are rare in the universe, and then identified clumps of stars moving along with them. After cross-matching and then removing known clusters, only one group of stars remained. This newly found cluster is still relatively young, just 117 million years old, and it's on the far outskirts of the Milky Way. The study's lead author, Adrian Price Whelan from the Flatiron Institute, says most of the Milky Way's young stars are in the galactic disk, but these stars are much further away, more distant than any other known young stars. This cluster is located right next to the Magellanic Stream. Now, unlike the rest of the environment in the outer reaches of the Milky Way, the gas in the Magellanic Stream is mostly neutral hydrogen, and so it doesn't contain much metal. Astronomers refer to all elements other than hydrogen and helium, which were created in the Big Bang, as being metals. The authors analysed the metallicity of the 27 brightest stars in the cluster, finding they had very low levels of metallicity, just like the Magellanic Stream. Price Whelan and colleagues think that the cluster formed as gas from the Magellanic Stream passed through the gases in the outer region of the Milky Way. As they did so, they created a drag force which compressed the Magellanic Stream gas. This drag, along with tidal forces from the Milky Way's gravitational tug, condensed the gas enough to trigger star formation. Then over time, the stars moved ahead of the surrounding gas, joining the Milky Way. If correct, these stars represent a unique opportunity to accurately determine the stream's distance from the Milky Way. Using the current positions and movements of the stars in the cluster, the authors predict the edge of the Magellanic Stream could be just 90,000 light-years away, roughly half the distance previously estimated. Now, if the Magellanic Stream is closer, then it's likely to be incorporated into the Milky Way much sooner than what current models predict. The updated distance to the Magellanic Stream will also improve our models of where the Magellanic Clouds have been and where they're going. The improved data could even settle debate over whether the Magellanic Clouds have crossed through the Milky Way before. And finding an answer to that question will help astronomers better understand the history and properties of our own galaxy. You're listening to Space Time. Coming up next, will the first humans to Mars come home with brain damage from radiation exposure? And Soyuz returns safely to Earth, carrying 3 Expedition 61 crew members from the International Space Station. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, the Great Courses Plus. You know, they say knowledge is power, and thanks to the Great Courses Plus, we get to tap into this power with just a click. Now, I often talk about this brilliant streaming service because it's brilliant, it's great. You can unlock unlimited access to objective, reliable, fascinating information on virtually any topic you want, from science to playing a musical instrument, to history, to cooking, even learn a new language. By using the Great Courses Plus, you'll be taught by some of the brightest minds in the world, benefiting from their years of experience and unique insight to help formulate our knowledge and perspectives. With over 40,000 5-star reviews in the Great Courses Plus, you're guaranteed to find compelling content, no matter what the subject. And today, I want to tell you about a great new course that I've been looking at, which I can highly recommend. It's called Experiencing Hubble, Exploring the Milky Way, and it's presented by Professor David Meyer from Northwestern University, where he's also the director of the Dearborn Observatory. And for David, and I've got to agree with him, there simply is no better way to communicate the joy of discovery in astronomy than through those stunning cosmic images obtained through the Hubble Space Telescope. Now, in this new course, he explores the latest spectacular imagery from Hubble, giving us the science and background stories to each image. And of course, these images really are mesmerizing. So, you really should check it out for yourself, Experiencing Hubble, Exploring the Milky Way. And of course, you can do it for free with our special offer. Join us and thousands of others who have experienced the sheer wonder of the universe by signing up for the Great Courses Plus. And for a limited time, Spacetime listeners will get free unlimited access to the entire Great Courses Plus library for an entire month. And believe me, you'll need it, with thousands upon thousands of courses to explore and choose from. But to get our special offer, you'll need to use our special URL, thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. That way they'll know you came from us and you'll be helping to support Space Time while at the same time opening up a fascinating new world of learning when you want it and how you want it. So why not sign up today and start your free month-long trial? Just go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space, and of course we'll have the URL details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to the show.
This is Space Time with Stuart Gary.
A study reported in the journal eNeuro has found that exposure to chronic low-dose radiation, the sorts of conditions present in deep space, would cause neural and behavioral impairments in astronauts. Researchers found the radiation exposure impaired cellular signaling in both the hippocampus and prefrontal cortex, and this could cause learning and memory impairments. Scientists also observed increased anxiety behaviors, suggesting radiation from deep space travel also impacted the amygdala. The findings suggest that 1 in 5 astronauts on deep space missions would experience anxiety, 1 in 3 would experience memory impairment, and all could experience difficulty with decision-making. Crew aboard the International Space Station don't experience these issues because it's in low Earth orbit, where it's protected from most forms of radiation by the Earth's magnetosphere. But beyond this protective shield, exposure to radiation increases. In fact, astronauts flying to the moon during the Apollo era reported seeing flashes of light, now known as cosmic ray visual phenomena, which scientists believe was caused by high-energy particles passing through the astronauts' eyes, optic nerves, and visual centers of the brain. The new results highlight the need to develop radiation protection measures in time for the first human journeys to Mars, flights which will involve well over a year of space travel, as well as another year and a half on the Martian surface waiting for planetary orbital alignment. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
If we're going to send people long distance, we're going to have to do it the old-fashioned way, and now it's starting to look like that might be more difficult than we first thought.
Yes, that's right. I mean, I think it's fair to say that of the technological problems that face us in terms of getting people, for example, to Mars, the radiation issue is perhaps the most difficult to solve. Yeah, you can provide your astronauts with an atmosphere. You can probably even build a spacecraft that will mimic the Earth's gravity by rotation, by, centrifugal force, all of those things. But what you can't do very easily without lots of shielding is stop the subatomic particles getting through the skin of the spacecraft. And in particular, it pertains to long-haul spaceflight, exactly as you say. So just looking at what we've done in human spaceflight so far, most of the experience of astronauts and the medicine that's been done with astronauts relate to scientists either in the International Space Station or its predecessors like Mir and Apollo-Soyuz and things like that. Those are long-duration spaceflight, but they're very much in the local environment. And all of those astronauts are protected to a large extent by the magnetosphere of the Earth, basically the magnetic shield that the Earth's magnetism builds around the planet. So certainly the International Space Station is well within that zone. Travel to the moon, of course, meant astronauts left that protective zone around the Earth, but their duration was not that much more than a week, of the order of 7 to 10 days. And that means that their dosages of the subatomic particles were relatively low. And so we don't have any direct experience of plonking people out there in the middle of nowhere and watch what happens when they're radiated by two specific sources. One is the solar wind, this wind of subatomic particles, basically electrons, protons and electrons from the sun. But the other, really maybe more dangerous one, is what's called the cosmic ray flux. So cosmic rays actually come from our galaxy and other galaxies. They're not from the sun itself. They're a background of subatomic particles that come from sources actually that are not that well defined. they are within our galaxy. There's probably a lot of stuff that results from neutron stars, stuff that results from perhaps black holes, from supernovae. All of that stuff is floating around, and we are irradiated with it. Actually, cosmic rays I think they were first measured before the First World War by scientists using balloons to see, to record what happened. So the cosmic ray flux, and particularly the high energy cosmic ray flux, is something that we, I guess, have recognized for quite a long time as putting long haul astronauts at risk. But now, some work that's been done by scientists, actually they're both the two scientists who published this work, they're both at University of California, Irvine, and they're both basically involved with radiation oncology. That's their specialism. And it's work that they have done in looking at relatively low doses, the kind of things that you might find irradiate astronauts traveling to Mars, but over long periods of time. And of course, they haven't used astronauts; they've used mice as basically as substitutes.
As you do.
As you do. So they did this for 6 months. They basically exposed mice to low-level neutron radiation for 6 months, and then looked at the neurons in their brains. In particular, these are the cells that essentially store memories and things of that sort.
And they concluded it's not a tumor.
Well, they concluded that they don't work very well anymore. Yeah. The fine structure in the neurons has been damaged, and maybe some of the connections have as well.
Oh.
So there were clearly in the their studies, of course, after the irradiation, they tested the mice to find out in behavioral terms how they were coping. And they say the outcome of our behavior studies demonstrated that mice exposed to neutrons for 6 months had trouble with learning, adapting, and storing memories. For example, these mice were less likely to be interested in a new toy that had been placed in their testing arena compared with a toy that they had already seen before. The control mice, on the other hand, would take much more time to explore the new toy than the old toy. And similar tests. But what was also really interesting is that the irradiated mice demonstrated social problems, much more likely to avoid social interactions, had difficulty dissociating or forgetting an adverse event that happened in the past. The space radiation induced changes that increased anxiety levels. So they essentially believe that they've replicated what would happen to a human brain in space. And they believe that this could significantly impair, once again quoting their work, significantly impair the ability of astronauts to respond under stress or in unexpected situations. And what they've done, they kind of translate those findings into what that might mean in human terms. And they say, we estimate that in a crew of 5 astronauts traveling to Mars and back, we would expect at least one member to display severe deficits in cognitive function by the time they return to Earth.
That is scary.
Yeah, it's very scary.
I mean, it could be all of them, couldn't it? It's statistically, it 1 in 5, but it could actually go the other way.
Yeah, that's right. They qualify their work by saying this is just one study and the results must be replicated, but it does raise the sobering possibility that galactic cosmic radiation exposure may represent a significant obstacle to deep space travel.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Three members of the International Space Station's Expedition 61 crew have returned safely to Earth aboard their Soyuz MS-13 capsule. The spacecraft touched down under clear blue skies, landing in 30 centimeters of snow on the freezing Kazakh steppe.
Standing by for engine firing. I confirm engine activation and firing.
Team's confirming that the deorbit burn started. That'll last 4 minutes and 39 seconds till 2:23 a.m. The engine firing acts as a brake to slow the Soyuz down while it's about 272 miles above the Earth.
Deactivation confirmed.
Separation. And there you go. Sounds like they are now separated. That again takes place when the Soyuz is 87 miles above the Earth. About this time, the heat shield is being put to the test, and the crew members are beginning to feel more and more pressure, or G loading.
What is the G load? We have 4.28 right now. We copy.
And the And the flight control team in Russia is seeing some video of the Soyuz making its way down already beneath that main parachute that will continue slowing the Soyuz down to 15.6 miles per hour. Great view of the Soyuz under the main parachute. Not as cloudy as predicted, it looks like. A very clear view.
No issues.
Inside the capsule there, Christina Koch, Luca Parmitano, and Alexander Skvortsov are just minutes away from their triumphant return to Earth. That should be taking place around 3:12 a.m. Central Time. So still another 10 minutes for them to slow down as they make their way toward the Earth. As they get closer, just about 2 seconds before they touch down, so Skvortsov will get a notice from the computer to fire 6 solid propellant engines called the soft landing engines to slow the Soyuz down to 5 feet per second, or about 3.5 miles per hour.
0.5, 0.3.
Helicopters who've made their way out to the landing site ready to meet them. About 8 helicopters are going to converge on the landing site with a number of support personnel from NASA and Roscosmos.
Standing by for the report.
What a ride.
3 minutes.
Soyuz MS-13 continuing its smooth descent on a way to a 3:12 a.m. landing in Kazakhstan.
2,800 meters. This is the current altitude.
All looking good so far as it makes its way down. Just a few more minutes now left in Christina Koch's record-breaking spaceflight. 328 days in space, just about to come to an end with this upcoming touchdown. Inside Christina Koch, Luca Parmitano, and Alexander Skvortsov.
Copy all.
Again, one of the last things to happen here will be the firing of the soft landing engines. That'll happen just a couple of seconds before the actual touchdown, when it's about 39 feet above the Earth. That's 6 solid propellant engines that are intended to soften the blow of landing just a little bit. Soyuz also has seat shock absorbers that will be turned on by now, prepared for that landing. And the seats themselves are contoured to fit the astronauts individually to provide them the softest possible landing, although all reports are that it still is not quite soft.
Landing site.
And it looks like Soyuz MS-13 carrying Christina Koch, Luca Parmitano, and Alexander Skvortsov has touched down 3:12 a.m. Central Time, right on time.
Skvortsov is out of the spacecraft. He will be helped down the slide. That's part of this ladder apparatus at the top hatch of the Soyuz. He's waving, smiling broadly, thumbs up. And he is now back on terra firma.
Alexander Skvortsov certainly looks like he's glad to be home. Pumping his fist into the air, shaking hands, lots of well-wishers on hand.
Christina Koch, you're a record holder. She is out, thumbs up, and a huge smile.
She definitely looks glad to be home. Again, 328 days that she's spent in space since her launch on March 14th.
And she'll be brought to her chair. Christina, welcome home.
Current record holder for longest single space flight by a woman of any nationality, and seventh most spaceflight time accumulated by an American astronaut.
Very impressed and very happy to be breathing this nice cold air on this Thursday afternoon. Big thumbs up for Luca Parmitano being helped down the slide. He is no stranger to Soyuz landings, of course. And Koch and Skvortsov are giving a big fist bump to their mate, number 1.
Looks like you've got 3 happy astronauts there. Glad to be back to the ground.
While on station, the 3 crew members had participated in over 210 scientific experiments, including research into how the human body adjusts to weightlessness, isolation, radiation, and stress during long-duration space flights. These data will help NASA prepare for America's return to the moon through the Artemis program, as well as setting the foundations for human exploration of Mars. You're listening to Space Time. Still to come, Iran fails in its latest attempt to launch a satellite into orbit, but on the other hand, the launch was very successful if it was actually a ballistic missile test. We look at efforts to preserve the night sky from light pollution. And later in the science report, scientists discover ancient virus and bacteria in ice core drill samples from Tibet. All that and more still to come on Space Time. Iran has failed in its latest attempt to launch a satellite into orbit, but the launch was very successful if it was actually a ballistic missile test. Either way, the flight marked another breach of Tehran's nuclear weapons ban treaty. Ratified by the United Nations Security Council Resolution 2231, it prohibits the Islamic Republic from developing ballistic missiles capable of delivering thermonuclear warheads. North Korea got around a similar problem by claiming their intercontinental ballistic missile tests were actually satellite space launches. And lo and behold, once they perfected their missile technology, Pyongyang lost all interest in space flights. The Sophia rockets Iran used for its first satellite launches were based on its Shahab-3 long-range ballistic missile, which itself was derived from the North Korean Hwasong-7 missile, which is based on the old Soviet Union Scud missile. The larger and more powerful Sophia 2A or Simorgh rocket used for Tehran's latest space flights is virtually identical to the North Korean Taepodong-2 Unha-3 long-range ballistic missile. The 27-metre tall, 2.5-metre diameter booster weighs some 87 tonnes and uses 4 liquid-fueled Shahab-3 Scud missile rocket motors with steering provided by 4 small Vernier engines. Like its North Korean counterpart, the Simorgh was a 2-stage launch vehicle, but designed to be fitted with a small 3rd stage powered by a solid rocket motor. This latest Iranian launch was meant to place the 113-kilogram Zafir or Victory in Farsi satellite into a 600-kilometre high orbit. It was meant to celebrate the 41st anniversary of the Islamic Revolution and as a prelude for crucial Iranian parliamentary elections. Back in 2018, the United States pulled out of the Iran nuclear deal, citing multiple violations by Tehran, including the continued missile tests. Other concerns surrounded continued support and sponsorship of terrorist organizations, including Hezbollah, Hamas, and Islamic Jihad, and continuing secret development of what's suspected to be a parallel nuclear weapons program with help from North Korea. Pyongyang has now tested and miniaturized its thermonuclear warheads to fit on their missiles, and the International Atomic Energy Agency says the Islamic Republic has been exploring various fusing, arming and firing systems to make its own missiles more capable of reliably delivering a thermonuclear warhead. Despite a series of successful space launches, in January 2019, Tehran failed to place its Panem or message satellite into orbit, and then in September last year, another missile exploded on the launch pad at the top-secret Imam Khamenei launch facility during a static test. You're listening to Space Time. Still to come, preserving the night sky from light pollution. And later in the science report, a new study has found that teens are struggling to control their impulses online. All that and more still to come on Space Time. One of the great sights in the southern night skies is the iconic constellation of the Southern Cross. However, if you're in the city, the stars of the Southern Cross are lost due to the glare of light pollution. And even in the suburbs, not all the stars in the cross are visible. It's a growing problem for skywatchers right around the world. An increasing majority of people can no longer see the true beauty of the night sky from their homes. In fact, for many of our listeners, the sight of the Milky Way stretching across the night sky is just a childhood memory. And today, sadly, an entire generation is growing up having never seen our own galaxy, the place we call home in the universe. Astronomers define light pollution as artificial light that shines where it's neither wanted or needed. Light from poorly designed, incorrectly directed light fixtures shines brightly into the sky. There it's scattered by air molecules, moisture and aerosols in the atmosphere, causing the night sky to light up, a phenomenon known as sky glow. And it's not just sky watchers who are affected, as anyone who suffers from a badly positioned streetlight shining in their bedroom window at night knows. More importantly, it also has numerous direct impacts on the environment, putting a huge strain on wildlife in both urban and rural areas, who become disoriented by the bright lights. The editor of Australian Sky and Telescope magazine, Jonathan Nally, says dark sky preserves are being established around the world to help combat the problem, And now there's one in Australia.
Big news recently is that 3,000 square kilometres of South Australia's Mid-Murray district have been declared Australia's first dark sky reserve.
Now, what does that mean?
It's an official thing where it's officially designated by the International Dark Sky Association, and that means that that area is great for viewing the night sky, and the people who live in that area, the businesses that run in that area, the governments that control that area are all going to work together to try to preserve quality of the night sky, you know, with good lighting and that kind of thing.
So this is lighting that looks downwards, not upwards?
Yeah, you don't shine your light up into the sky so the sky glows, because the sky actually glows. I mean, it glows blue during the day because there's lots of light to illuminate it. That's the
Rayleigh
sunlight,
scattering,
of course.
yeah.
But even at night time, the sky is not pitch black if you live in a city. If you go out and look in the sky in the night in a city, you'll see that the sky looks grey, actually. It's not pitch black in between the stars. It should be pitch black. And the amazing thing about this area, which is what they're calling the River Murray International Dark Sky Reserve, it's only 90 minutes drive from Adelaide, by the way, but on a scale of 0 to 22, with 22 meaning perfect dark skies, this region scores between 21.91 and 21.99 out of 22.
Wow.
So you don't get much better than that. It's a really great spot, so it's great that they've done that. So it's Australia's first dark sky reserve. Now, across the Tasman in New Zealand, they already have some dark sky reserves, and they're wanting to go even one further. There are plans afoot, or there are people pushing for, to make New Zealand an entire dark sky nation, because New Zealand has the most beautiful skies, and it's a big tourist attraction. You know, there are lots of tourism operations that revolve around astronomy, and there are going to be more and more of them. So they just want to preserve the quality of the night sky because it's a really important thing. And that doesn't mean everyone has to turn off all their lights and that kind of stuff. It just means being sensible about how we illuminate ourselves and the ground during nighttime hours, and do it in such a way that it preserves the quality of viewing the night sky for everybody, for not just our generation but generations to come. So that's really tremendous, isn't it? So we've got this magnificent dark sky reserve in South Australia, and there are some other sort of one step removed from dark sky reserve down the sort of ladder of, or the hierarchy of dark sky sites. There are a couple of other places in Australia that are, you know, already designated something slightly less than that. And across the Tasman in New Zealand, yeah, they're going for Dark Sky Nation. So good on them, I say. We need more of this.
I used to regularly drive from Darwin to Sydney. I was working in Darwin, and I used to have my holidays in Sydney. And when I was doing those drives on a regular basis, there was just nothing like stopping at a truck stop in the middle of the outback and looking up at the night sky for an hour or so and just seeing that spectacular vista, that velvet black sky. Absolutely amazing.
Yeah, it really is amazing, isn't it? It's so dark out there that here's something you can try for people who live in the cities, to do a bit of a comparison. If you do get to a dark sky spot where you're really far away from the lights of towns, and if there are some clouds in the sky. So if you've got clouds in the sky in the city at night time, you will see the clouds because the light shining upwards from all the lights we've got down on the ground illuminate the cloud, and you can see the cloud. The clouds look white or grey or whatever they are at night time. But if you go out in the outback or the bush or anywhere where it's really, really dark and there are some clouds in the sky, they look black. They're like big black holes blocking out the stars because there's nothing to illuminate them from below.
Wow.
Yeah, it's really quite striking. Of course, if you could see them side by side, the two things side by side, you get a better idea of it. But if you go out, if you live in the city and you go outside one night and there are some clouds in the sky, nice fluffy cumulus clouds, whatever, you'll be able to see them as clouds. But you go out into the bush when there's no moon, dark skies, and the clouds will look black.
When you see images of Earth at night from the International Space Station, you see air glow, this yellowy, greeny sort of tinge on the sky, which is caused by the excitation of molecules in the atmosphere. You don't notice that air glow from looking up from below.
No, you don't. But looking down, you sort of you do get a better perspective on that, particularly if you can look sort of sideways through the atmosphere.
Yeah.
Which you can do from up in orbit, which we really can't do.
Of course, yes, that makes sense.
From down here, yeah. But those pictures of the Earth at night show you, I mean, they look look beautiful, don't they, with all the twinkly little lights and things, but you look at those and think, what's the point of having that light shining upwards? There's absolutely no point. The lights are not there to illuminate upwards. They're there to illuminate the ground below. So those lights are not good lights. They're shining their light. Presumably some of it's going onto the ground where it needs to be, so we can see where we're going, but the rest of it's shining up into the sky. I mean, it's just pointless. It's really bad lighting design, and it's just wasting energy. Astronomers have been banging on about this for decades now, and the good thing is that whereas before a lot of people wouldn't really take notice, it's just astronomy, who cares? But now, of course, it's an environmental problem as well. So lots of people getting involved in it, and more power to them, I say, because using proper lighting uses less power.
Yeah, but what we're finding now is because it's so cheap to run LEDs instead of the old incandescent lighting, people are leaving the LEDs on for longer, and they're installing more of them. So because it's so cheap, we're actually seeing an increase in the amount of light being emitted.
Yeah, I guess it's just the same as any other thing that we don't notice. They say, particularly with light pollution, is by the time you notice there's a problem, it's too late to fix the problem.
Yeah.
The classic example is Australia's major optical observatory site, Siding Spring up in Coonabarabran in sort of mid-New South Wales. You can see the sky glow of Sydney on the horizon. That's hundreds and hundreds and hundreds of kilometres away in a direct line. Whether it's leaving our LED lights on longer or permanently because it's cheap, or whether it's any sort of other kind of pollution, unless we stop to think about it, then nothing really changes.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that Arctic ice melt caused by global warming is changing ocean currents. The findings, reported in the journal Nature, are based on 12 years of NASA satellite data measuring how the influx of cold fresh water is affecting the Beaufort Gyre, a major Arctic current. The authors found the current is moving faster and become more turbulent as a result of rapid sea ice melt. The current, which flows in a clockwise direction around the western Arctic Ocean north of Canada and Alaska, is now flooded with fresh water. This fresh water is important in the Arctic, in part because it floats above the warmer salty water and helps protect the sea ice from melting, which in turn helps to regulate the Earth's climate. The Gyre also slowly releases fresh water into the Atlantic Ocean, allowing the Atlantic currents to carry it away in small amounts. But since the 1990s, the Gyre has accumulated some 8,000 cubic kilometres of fresh water, almost twice the volume of Lake Michigan, due to the loss of sea ice in summer and autumn. Normally, water from the Arctic loses heat and moisture into the atmosphere and sinks to the bottom of the ocean, where it drives water from the North Atlantic Ocean down into the tropics like a conveyor belt. This important current, called the Atlantic Meridional Overturning Circulation, helps regulate the planet's climate by carrying heat from the tropically warmed water to northern latitudes like Europe and North America. Now, if slowed enough, it could negatively impact marine life and the communities that depend on it. Scientists say they're not expecting the Gulf Stream to suddenly shut down, but they do expect some impact. A new study claims probiotic bacteria, commonly used in yogurt and cheese production, triggers an array of anti-inflammatory immune changes in human blood cells, which could potentially help autoimmune and inflammatory disorders. The researchers found that the bacteria, known as Streptococcus thermophilus, can change the expression of genes involved in the immune response of human blood cells. And this in turn changes their production of immune signaling molecules. You can read the findings in full in the journal PLOS ONE. New researchers found that teens are struggling to control their impulses online in a scramble for cheap thrills and a self-delusional sense of power. A report in the European Journal of Criminology found this internet addiction potentially increases the risk of becoming cybercriminals. Researchers analysed existing links between legal online activities and cybercrimes, such as how viewing online porn can progress to more and more depraved illegal content, and motivations to evolve from online gaming to hacking. Scientists have found ancient viruses and bacteria in 2 ice core drill samples taken from a summit and plateau region in northwestern Tibet. While glacier ice cores can provide climate information over tens to hundreds of thousands of years, study the microbes in these samples has always been difficult because of the ultra-low biomass conditions. Furthermore, virtually nothing is known about any co-occurring viruses. So, scientists from Ohio State University set up ultra-clean microbial and viral sampling procedures in order to study two ice cores taken from 520 and 15,000-year-old glacier ice. They found the microbes differed significantly across the two cores, presumably representing very different climatic conditions at the time of deposition. Collectively, the samples contained some 254 genera of bacteria and 33 viral populations that represented 4 known genera and likely 28 novel viral genera. And 18 of the viral populations are found to have infected some of the more abundant bacterial groups. Have you ever fought the urge to yawn when someone near you has yawned first? Well, you may have noticed dogs will do the same thing. And researchers have long thought this was likely due to the empathy that develops due to the close relationship between dogs and their human companions. But a new report in the Proceedings of the Royal Society B has cast doubt on this hypothesis. Scientists have reanalyzed the data from previous experiments, finding that a dog's tendency to yawn wasn't affected by whether the person was familiar or unfamiliar to the dog, friendly or unfriendly, or even whether the dog was male or female. The results suggest contagious yawning and empathy don't share cognitive mechanisms. New research claims more than a third of Australians have become convinced they've got some sort of life-threatening illness after using Google to research their symptoms. The study of more than 1,500 people found half were using Dr. Google weekly to look up medical information, and 72% had used the search engine for medical advice at least once rather than visiting a doctor. Tim Mendham from Australian Skeptics says the study also shows that at least 60% found they'd actually misdiagnosed their illness after finally visiting their doctor.
You've got to put this in context that about apparently 80% of people online are using the internet to search for health information. And that largely means Dr. Google. I need information on this particular condition which I have or which I believe I have, which is a great worry that there's no discernment there as to the quality of the sites or the information you're going to. NBC News in America did a study looking at the whole range of sort of social media-based promotion of misinformation, as they say, on health areas. The two biggest areas that they found was operating with cancer cures and vaccination. Cancer is a pretty, very serious issue. Everyone's quite concerned about it. Obviously, if not for themselves, then for people they know. So it comes up as a very major area for people who are promoting all sorts of different cures, etc. Then, allied to conspiracy theories, of course, at the same time, there's a fellow who sells dietary supplements, and he sort of puts up all sorts of conspiracy theories and dodgy products and things, and his theory is that, quote, cancer industry not looking for a cure, they're too busy making money, and that got about 5.5 million engagements on his website, which is generally regarded as one of the worst websites out there for information or misinformation. So these things get a lot of coverage, people get worried, conspiracy theories, etc., especially when it comes to health, which is obviously a very personal thing, and people need assurance. Then all sorts of different health cures are promoted. Ginger is one that's been promoted recently. Someone says it's 10,000 times more effective at killing cancer than chemo. Papaya juice, elderberries, dates, thyme, garlic, jasmine, limes, okra, herbs, veggies, exotic fruits, everything to cure cancer, diabetes, asthma, the flu, you name it. There's always a site out there to promote something, and some of these are highly successful, using Facebook, using Twitter, using all sorts of social media applications and pointing towards their websites. On the anti-vax side, there's some major players here who someone suggested that more than half of the promotion for anti-vaccination, whether it's advertising or whether it's sort of just items on the website, on Facebook, etc., comes from 3 different people or different groups. And if so much of the anti-vaccination stuff is coming from so few people that they're using social media and using sharing, etc., to get the message out, that they have an impact way beyond their own immediate qualifications, which is none. So cancer cures, anti-vaccination are the 2 biggest areas by far that of misinformation put out there online and in social media.
You make it sound like the old saying that people online really are sheeple. May be true.
Yes, a lot of the audience out there, but judging by the numbers of people who are supporting these things, who are just, most people are just sort of searching out for information, that's fine, but they should search out from more than one place. The trouble is they don't necessarily do that. They go to the highest listing on Google and assume that because it's up the top of the list that it must be authoritative, and it ain't so. So, people need to be taught to be discerning, need critical thinking, believe it or not, but they don't. They don't apply critical thinking to the most important areas, which is health and their well-being.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download Spacetime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, CastBox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the Spacetime online shop and grabbing yourself a few goodies, or by becoming a Spacetime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more Spacetime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at Spacetime with Stuart Gary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.